Pure JavaScript is Unicode friendly but not nice to binary data. When dealing with TCP streams or the file system, it's necessary to handle octet streams. Node provides buffer class which provides instances to store raw data similar to an array of integers but corresponds to an raw memory allocation outside the V8 heap. Node buffer can be constructed in a variety of ways. The first syntax is to create an uninitiated buffer of 10 octets. The second syntax is to create a buffer from a given array. And the third syntax is to create a buffer from a given string and optionally an encoding type. Writing to buffers. The syntax for writing to a buffer consists of the string offset length and encoding parameters. String parameter is the string data to be written to the buffer. Offset is the index of the buffer to start writing at. The default value is 0. The length is the number of bytes to write, and the default is buffer.length. And next, encoding is the UTF-8 or any other encoding format which needs to be written to the buffer. Some other functions associated with buffers are concatenation of buffers. In this, we pass the list and the total length of the buffer. And next, we can also compare the buffers by passing the other buffer as the parameter. We can also copy buffer from one to another by passing the target buffer, target start index, source start index, and source end index. We can also slice the buffer by passing the starting index and the ending index. And we can also find the length of the buffer by using buff.length. Let us look at the concept of streams. Streams are objects that let you read data from a source or write data to a destination in a continuous fashion. There are different types of streams. First one is a readable stream. This is a stream which is used to which is used for a read operation. Next one is a writable stream. This is a stream which is used for write operation. Next is duplex. This is a stream which can be used for both read and as well as write operation. And another type of stream is transform. It is a type of duplex stream where the output is computed based on input. Each type of stream is an event emitter instance and throws several events at a different instance of times. For example, some of the commonly used events are data, end, error, finish. Data is an event which is fired when there is a data available to read. End is an event which is fired when there is no more data to read. Error is an event which is fired when there is an error received or written to or writing a data. Finish is an event which is fired when all the data has been flushed to an underlying system. Let us look at an example for reading and writing to a stream. This is a program to read a stream. First, we create a reader stream by using create read stream function and passing the input.txt as the parameter. We set the encoding format to UTF-8. Then we handle the stream events, that is data, end and error, by using this function. In this, we keep on appending the chunk to the data, and when there is an end event detected, we print the data onto the console, and when there is an error event emitted, we print the error stack onto the console. Let us try to run this program. We can see that the data is printed on the console. This is a program which writes to a stream. First, we take a random string and store it in data. Then we create a writer stream by using create write stream and passing output.txt as the parameter. In this, all the data will be uploaded to the output.txt file. Next, we write the data to the stream with the encoding format of UTF-8. We use the function write and pass the first parameter as the data and second parameter as the encoding format. Then we mark the end of the file by using the function writerStream.end. Then we handle the stream events finish and the error. First, we register the finish event with a function where it prints the write completed onto the console. Then we bind the error event with a function where it prints um, error stack onto the console. Now let us try to run this program. This output shows us that it has completed writing into the output.txt file. Now let us open the output.txt file. We can see that the string simply easy learning has been printed to this output.txt stream. Let us look at another type of stream called as piping streams. Piping is a mechanism where we provide output of one stream as the input to another stream. It is normally used to get data from one stream and to pass output of that to stream. Let us look at another type of stream called as piping streams. Piping is a mechanism where we provide output of one stream as the input to another stream. It is normally used to get data from one stream and to pass output of that stream to another stream. There is no limit on piping operations. Now we will show a piping example for reading from one file and writing to another file. Let us look at the program. First, we create a render stream by using the input.txt as the parameter. Then we create a writable stream by passing the output.txt as the parameter. After creating the render and writer stream, we'll pipe the read and the write operations. The render stream dot pipe and passing the writer stream as the parameter will pipe both the render and the writer stream. It will read the input.txt and write data to the output.txt. Now let us run this program. This is the input.txt file. Let us open the output.txt file. We can see that all the string present in the input.txt file has been copied into the output.txt file. Let us look at another type of stream called as chaining stream. Chaining is a mechanism to connect output of one stream to another stream and create a chain of multiple stream operations. It is normally used with piping operations. Now we'll use the piping and chaining to first compress a file and then decompress the same. Let us look at that program. In this program, you have to import the module zlib to compress the file. First, to compress the input.txt file, we have to create a read stream. Then we have to pipe the create gzip function which is present in the z library file. Then we have to create a write stream and passes all the string data to the compressed input.txt.gz file. The output zipped file will have this as the title. Let us run this program. We can see that file has been compressed. We can see that the zipped file has been created. Let us try to decompress this file. This is the decompressed input.txt file. Let us open this file. We can also decompress the file using a program. This is the code to decompress the input.txt.gz file. Let us try to execute this program. We can see that the file has been decompressed. Let us open that file. We can see the decompressed text file. This is the end of the concept called streams. Streams is a very useful and very important concept